Introduction to AWS IAM Anywhere. Welcome to our comprehensive deep dive into AWS IAM Anywhere. This is one of the most powerful and misunderstood services in AWS, so we're going to break it down step by step. Think of IAM Anywhere as a bridge that allows your on-premises servers, containers, or applications to securely authenticate with AWS using certificates instead of long-lived access keys. It's like having a VIP pass that proves who you are without carrying around sensitive credentials. Traditional AWS authentication requires storing access keys on your servers, which is risky. IAM Anywhere eliminates this risk by using short-lived, certificate-based authentication. It's more secure, easier to manage, and follows the principle of least privilege. By the end of this presentation, you'll understand exactly how to set up, configure, and troubleshoot IAM Anywhere in real-world scenarios. Understanding the core architecture. Let me walk you through how IAM Anywhere actually works under the hood. Understanding this flow is crucial for successful implementation. The process starts with a certificate authority, or CA, that you trust. This could be your company's internal CA or a third-party provider. The CA issues certificates to your workloads. Think of these as digital identity cards. When your application needs to access AWS, it presents its certificate to IAM Anywhere. The service validates the certificate against your trusted CA, then exchanges it for temporary AWS credentials, typically valid for 1 to 12 hours. This diagram shows the complete authentication flow. Notice how the credentials are temporary and automatically expire, eliminating the risk of credential theft that comes with long-lived access keys. The beauty of this system is that your applications never store permanent AWS credentials. Even if a server is compromised, the attacker only gets temporary, limited-scope credentials that will expire soon. Setting up your trust anchor. Now let's get hands-on with creating your first trust anchor. This is the foundation of your IAM Anywhere setup. It tells AWS which certificate authority you want to trust. The CLI command we're using here is roles anywhere create trust anchor. Let me break down each parameter for you. The name parameter is just a friendly identifier. Choose something descriptive like company CA production, so your team knows what it's for 6 months from now. The source parameter is where the magic happens. We're specifying that we want to use a certificate authority as our source, and we're providing the CA certificate in PEM format. The certificate data must be base64 encoded and properly formatted. In real environments, you'll typically read this from a file, using something like source certificate authority ARN, and piping it to base64. When this command succeeds, AWS gives you back a trust anchor ARN. Save this. You'll need it when setting up profiles and roles. Creating IAM roles for IAM Anywhere. Regular IAM roles won't work with IAM Anywhere. We need to create special roles with a specific trust policy. This is where many people get stuck, so let's go through this carefully. The trust policy is the key difference. Instead of trusting an AWS service or user, we're trusting the rolesanywhere.amazonos.com service. This tells AWS that this role can be assumed through IAM Anywhere. The conditions section is crucial for security. The string equals condition specifically with the AWS principal tag by 0.509 subject CN means that only certificates with a specific common name can assume this role. This is how we implement fine-grained access control. You can use various certificate fields for conditions. Common name, CN, organization, O, organizational unit, OU, country, C, state, ST, and more. This gives you incredible flexibility in mapping certificates to permissions. The role policy document file contains standard IAM permissions. Start with minimal permissions and expand as needed. The principle of least privilege is your friend here. Let's look at configuring your profile. The profile is what ties everything together. It connects your trust anchor to your IAM roles and defines which applications can access what resources. When you run roles anywhere create profile, you're essentially creating a configuration that allows applications with certificates from this trust anchor to assume these specific roles. The role ARN parameter accepts multiple roles, which is powerful. You might have one role for read-only access and another for write operations. letting your applications choose the appropriate level of access. The session duration minutes parameter controls how long the temporary credentials last. Shorter durations are more secure but require more frequent credential refreshes. I typically recommend 60 minutes for most applications. The Require Instance Properties flag is optional but recommended. When enabled, it adds additional security by requiring the application to provide instance metadata, making it harder for stolen certificates to be used from unauthorized locations. Once created, the profile gives you another ARN that your applications will reference when requesting credentials. Installing the AWS Signing Helper. The Signing Helper is a crucial component that does the heavy lifting of certificate-based authentication. It's a command-line tool that your applications use to exchange certificates for AWS credentials. The installation process varies by operating system, but the concept is the same everywhere. You're installing a tool that can read certificates, communicate with IAM Anywhere, and return temporary AWS credentials in a format that AWS SDKs understand. For production environments, I recommend downloading a specific version rather than using latest to ensure consistency across your infrastructure. The GitHub releases page has checksums you should verify for security. The Signing Helper needs to be executable and accessible to your applications. Many teams place it in user local bin on Linux systems or create a dedicated service account that runs it. Once installed, you can test it with the version flag to ensure it's working correctly. The Signing Helper is what translates between the certificate world and the AWS credentials world. Generating your certificates. Now we need to create the certificates that our applications will use. This step is critical because the certificate properties directly map to your IAM role conditions. The private key generation creates a 2048-bit RSA key. In production, you might want 4096-bit keys for additional security, but 2048-bit is the current industry standard and supported by all AWS regions. The certificate signing request, CSR, contains the identity information. Pay special attention to the common name, CN field. This must match the condition in your IAM role trust policy. The OpenSSL rec command creates the CSR interactively, but you can also provide all values via command line flags for automation. The nodes flag means no password protection on the private key, necessary for automated processes. In real environments, you'd send this CSR to your certificate authority for signing. The CA returns a signed certificate that proves the identity is valid and trusted. Keep the private key secure and never share it. The certificate can be shared freely. It's public information that proves identity, but can't be used for authentication without the corresponding private key. Obtaining AWS credentials. This is where everything comes together. We're using the Signing Helper to exchange our certificate for actual AWS credentials that can be used with any AWS SDK or CLI. Let me break down this credential process command, parameter by parameter, because this is where many implementations go wrong. The certificate parameter points to your signed certificate file. This proves who you are to AWS. The private key parameter points to the corresponding private key. This is kept secret and used to cryptographically prove you own the certificate. The trust anchor ARN must exactly match the trust anchor we created earlier. This tells IAM Anywhere which CA to validate against. The profile ARN specifies which profile configuration to use, determining which roles you can assume, and for how long. The role ARN is the specific IAM role you want to assume for this session. You can only choose from roles listed in your profile. When successful, this returns standard AWS temporary credentials, access key ID, secret access key, and session token. These work exactly like any other AWS credentials. Integrating with AWS CLI. One of the most powerful features of IAM Anywhere is its seamless integration with the AWS CLI. Instead of manually running the Signing Helper each time, you can configure the CLI to automatically handle certificate-based authentication. The credential_process configuration tells the AWS CLI to run an external program to fetch these credentials. This happens automatically whenever you run AWS CLI commands, requiring no manual intervention. The CLI caches these credentials until they expire, so you avoid the overhead of certificate exchange on every command. This makes the user experience identical to using traditional access keys, but much more secure. You can have multiple profiles in your AWS config file, each using different certificates or assuming different roles. This gives you role-based access switching without managing multiple sets of access keys. The region setting is important, because IAM Anywhere is a regional service. While the credentials work globally, the authentication itself happens in a specific region. So choose one close to your infrastructure for best performance. Real-world implementation example. Let's see how this looks in a real application. This Python example shows how to use IAM Anywhere credentials in your code without any special libraries or modifications. The beauty of this approach is that your application code doesn't change at all. The AWS SDK automatically uses whatever credentials are configured, whether they come from IAM Anywhere, EC2 instance roles, or traditional access keys. The subprocess call to auth_signing_helper returns credentials in the exact format the AWS SDK expects. You're essentially replacing the built-in credential providers with your certificate-based one. Error handling is crucial here. Network issues, expired certificates, or misconfigured roles can all cause credential acquisition to fail. Always implement proper retry logic and fallback mechanisms. For production applications, I recommend wrapping this credential fetching in a class that handles caching, refresh timing, and error recovery. The credentials have a limited lifetime, so you need logic to refresh them before they expire. Many teams create a local credentials service that handles all the certificate management and provides a simple API for applications to get fresh AWS credentials. Security best practices. Security is paramount with IAM Anywhere, so let's talk about the essential practices that will keep your implementation secure in production. Certificate rotation is critical. Unlike access keys that might live forever if forgotten, certificates have built-in expiration dates. Plan your rotation strategy before going to production. Automated renewal is much better than emergency renewals at 2 a.m. The principle of least privilege applies heavily here. Start with minimal permissions and add only what's needed. The role conditions in your trust policies should be as specific as possible. Use certificate fields like OU or L to segment access by team or environment. Monitor credential usage through CloudTrail. Every role assumption generates events that you can alert on. Unusual patterns might indicate compromised certificates or misconfigurations. Certificate storage requires careful consideration. Private keys should never be world-readable, and in containerized environments, consider using init containers or sidecar patterns to inject certificates securely. Network security matters too. IAM Anywhere endpoints should be accessed over HTTPS, and consider using VPC endpoints to keep traffic within your AWS network. Common troubleshooting scenarios. Let's go through the most common issues you'll encounter with IAM Anywhere and how to solve them. These represent probably 90% of the support tickets I see. Certificate validation errors usually mean there's a mismatch between your certificate and trust anchor. Check that the certificate was signed by the CA you registered, and verify the certificate chain is complete. Permission denied errors often come from incorrect role trust policies. The certificate fields must exactly match the conditions in your trust policy. Case-sensitive, exact strings only. Network timeouts can happen if your applications can't reach the IAM Anywhere endpoints. Check security groups, network ACLs, and proxy configurations. The service endpoints are region-specific, so ensure you're connecting to the right region. Expired credentials indicate your session duration is too short for your application's needs, or you're not refreshing credentials properly. Implement credential refresh logic before the current credentials expire. The AWS CLI debug mode is your friend for troubleshooting. Add debugged to see exactly what's happening during credential acquisition, including the full request and response from IAM Anywhere. Effective monitoring and logging are essential for production IAM Anywhere deployments. You need visibility into authentication patterns, failures, and security events. CloudTrail captures every IAM Anywhere API call, including successful and failed role assumptions. Set up CloudWatch alarms for failed authentication attempts. These could indicate attack attempts or misconfigured applications. The signing helper generates detailed logs when run with verbose flags. In production, configure centralized logging to collect these logs from all your servers. Patterns in the logs can help identify certificate rotation needs or configuration issues. Application-level metrics are crucial too. Track credential fetch times, success rates, and refresh patterns. Slow credential acquisition might indicate network issues or overloaded CA infrastructure. Consider implementing custom CloudWatch metrics for certificate expiration dates. You want alerts well before certificates expire to avoid service disruptions. Security teams should monitor for certificates being used from unexpected locations or at unusual times. This could indicate credential theft or lateral movement in a security incident. Cost optimization strategies. While IAM Anywhere itself has minimal direct costs, the implementation decisions you make can significantly impact your overall AWS bill and operational overhead. Session duration tuning is a balancing act. Longer sessions reduce API calls to IAM Anywhere but increase security risk if credentials are compromised. Shorter sessions are more secure but increase network overhead and latency. Regional deployment strategy matters for both cost and performance. Deploy IAM Anywhere in regions close to your workloads to reduce latency and data transfer costs. However, remember that credentials work globally once obtained. Certificate management automation saves significant operational costs. Manual certificate renewal processes are error-prone and expensive in terms of human time. Invest in automation early. It pays for itself quickly. Credential caching strategies can reduce API calls and improve application performance. Implement local caching that respects credential expiration times but avoids unnecessary refresh operations. Consider using IAM Anywhere for development and testing environments too. The improved security posture often justifies the small additional complexity compared to development-specific access keys. Advanced configuration patterns. As your IAM Anywhere implementation matures, you'll want to explore advanced patterns that provide additional security and operational benefits. Multi-environment strategies often use different trust anchors for different environments. Your production CA is separate from development, providing clear security boundaries and reducing the blast radius of any compromise. Certificate-based role mapping becomes powerful at scale. Use organizational units in certificates to automatically determine which roles an application should assume. This reduces manual role assignment and improves security through standardization. Conditional access policies can include time-based restrictions, IP address filtering, or MFA requirements. These advanced conditions provide defense in depth beyond basic certificate validation. Integration with existing PKI infrastructure often provides the best long-term value. If your organization already has certificate management processes, extending them to include AWS Access certificates maintains consistency and leverages existing expertise. High availability considerations include multiple trust anchors, cross-region failover, and offline certificate validation capabilities for critical applications that can't tolerate network dependencies. Thank you for your attendance.